My name is Terry Radickle. I'm the CEO of Second Sight Lab in Seattle, and I provide security consulting through my business, do some cloud security consulting, some pen testing. I'm also an instructor for SANS Institute. I help teach the cloud security architecture and operations class. And this is a new class. I'm really excited about it. It's got some papers that I wrote in there and some other writing. And obviously, if you want to take that, you can go up to SANS Institute, or if you want to take it with me, I would love that. I have times. I'm actually teaching that class on my website. So if you want to know more about my background, I have about 25 years of experience, and I'm going to refer you to the RSA guide or my website. Lots of things I've written out there if you want to take a look. There's a couple things I want to tell you that are related to this talk. So about 5 years ago, I was working at Capital One, and I wanted to use the cloud. And someone told me, just forget it. Capital One will never use AWS. So I said, fine. I went out and started moving my own things to the cloud, and I started the Seattle AWS Architects and Engineers meetup. And I wasn't sure how that was going to work out. The first meetup had 5 people, and then it grew. So now it has over 2,200 people in the group. And this is where I met Colby. Colby came to speak a couple times. He was really smart, and I thought, wow, he seems like he has a lot of knowledge. And as you know, if you follow AWS at all, Capital One did move to the cloud. They were the first major US bank to move to the cloud, and I was fortunate enough to be on that team. I helped them with a lot of the security controls and networking, and it was really a great learning experience. So at some point, WatchGuard Technologies came to me and said, hey, will you help us move to the cloud? And I said, sure. And when I got there, it's a smaller company, and I needed someone to help me on the team, and my DevOps team, and I was like, who can do this? Because at Capital One, this person would have been like 10 people, right? And the only person I could think of was Colby. So I didn't think he would take the job, but he did. He came over, and I had written a paper on secure CI/CD pipelines, and I wanted to kind of try it out, and Colby was on board. And so we were able to deploy this and deliver it for WatchGuard. Eventually, we moved on to other things, but Colby asked me to come here and speak with him at RSA, and I said, sure. So here we are.
Hi, I'm Colby. So I work for ZipWhip, a startup in Seattle. We are a text messaging company. We text-enable landlines and toll-free. So if you want to talk about that afterwards, more than open to that. As Terry said, we've worked together previously, both at WatchGuard and then through the meetup, which I am helping her co-lead. Before that, I was an IT consultant. Really jumped on board with the cloud stuff when AWS started getting big and helping clients move to the cloud. My background, though, is a little interesting. I started life as a chemist. I actually have a master's degree from UCLA in computational chemistry. I got really tired of chemistry after 8 straight years of studying it, so I moved into technology. And here we are.
OK, so what are we going to talk to you about today? We are going to talk about red team versus blue team on AWS. And as you can see from our lovely picture, I am the stealthy ninja, and I'm going to go attack Colby's account. And Colby is going to be Superman. He's going to come in and save the day and stop me. So I just want to get one thing out of the way up front. Red team is a term that goes in hand with pen testing, and people argue about what that is, and we're not here to do that. We're just saying one person's going to attack, one person's going to defend, and we're going to try to see what we can do here. So the first thing that I could do is I could go in and I could try to target your cloud admin's keys. And once I get those keys, I can basically do whatever I want. And we could use a lot of standard pen testing techniques to do this. There's a lot of other talks on these type of things, and we're not going to go there. We're not going to talk about kind of standard pen testing. But what I could do is I could get these credentials, and then I could do anything I wanted in your account. There's a company called Codespace, as you may have heard of, and I like to say it's the company that got deleted because all their work was in the cloud on AWS, and someone got those credentials, and they started trying to get money from the company. Company said no. They basically deleted everything that was out there. So if we did that, it would be game over, and it would be a really boring talk. So we decided we want to do something a little bit more interesting. We want to hunt for buried treasure. So what we decided to do, this is an AWS talk. We're not going to use standard, kind of things you might know about, Metasploit and things like that. We're going to use AWS tools. We're going to go on a treasure hunt. And I'm going to look for the gold in your account. And I like to say your data is like your gold. It's what's really valuable to you. So I'm going to see what I can do to get access to that.
So just as a primer to how the account was set up, we really wanted to treat this more as an example of you have a developer that you've enabled to go out and set up a cloud account and start testing the waters or bring some of your workload to the cloud. So we didn't follow any of the best practices that we normally do and that we're talking about. We just went out, set up an account, a very vanilla account, a single admin user. We used the base VPC, all the defaults that are available within Amazon, nothing special. And then we're like, well, I'm new to this Amazon thing, so let me follow some tutorials. One thing we want to do is present a website, so we had a public-facing thing to play with, and so we followed their tutorial to deploy WordPress. Now, both Terry and I done a lot of CI/CD, but we've never played around with Amazon's Elastic Beanstalk tool, so we chose a tutorial around it. It's an automated deployment tool that they have. And then just to make things interesting, and because databases tend to contain a lot of information, we decided, well, let's deploy a database. And what's a cool way to do databases? Well, serverless is the hot topic right now, so let's use AWS Lambda, which is their serverless system, and RDS, their hosted database system. And we followed this tutorial that set up how to talk Lambda to RDS. So the account, again, is just very basically set up. These tutorials will follow verbatim. We didn't do anything else. And then the account was then ready to go.
Okay, so for this talk, we're going to say, let's say I got a read-only key. Let's say that you want to be secure. You're trying to be secure in your account, so you don't give people complete access. You only give them read-only, because what harm could that do? They can't write. They can't deploy anything. So as you can see here, if you're familiar with AWS, when developers use the AWS CLI, they install it on their laptop, and then they get some credentials out of the account, and they're able to deploy these credentials. They run something called AWS Configure. They put these keys in there, and what happens is these keys get stored on their system, in their home directory, in a file, in a directory called .aws, and a configure file. And let's say I got on there and I got these keys, or let's say they publish it to a GitHub account, or I said, hey, can I borrow your keys really nicely, or they clicked on a phishing email, something like that. There's many ways I could get these keys. So what can I do with these keys? I mentioned that your database is like your gold, right? This is the thing you want to protect. And I worked in financial services. I worked for Capital One. I built back office systems. And I know that a lot of times data like that, as either PII or financial, is stored in a relational database, because relational databases are transactional and they have certain properties. So I'm going to guess that if you have some sensitive data, it's probably in a relational database, and on Amazon, that's the AWS RDS service. So I can run this query right here with my read-only key, and I can query and say, show me all the databases in your account. I want to see what's out there. And at this point, if I wanted to, I could go through each one and I can try to figure out, which one do I want to attack, which one do I want to try to get into. But for starters, I can just look at the names and say, what looks interesting to me here? And Colby has very nicely named one of these databases the Super Secret DB. So that looks cool. I'm going to go after that one. So here we go. We're going to go to the next step and try to see how can I get into that database. So what's going to stop me in a cloud account from getting to that database? One of the things I have to get through is the networking. On Amazon, you can create virtual private clouds, and things in virtual private clouds can talk to each other, and things outside of that cloud depending on how you configure your network. And one of the things I have to get through is the subnet layer. So I'm going to go query for that super secret DB, what are the subnets associated with that instance? And what I find here is there are 2 subnets. And the next thing I'm going to do is I'm going to find out what rules are associated with that subnet. So a subnet has NACL rules, or Network Access Control List. And these rules say what can go in and out of that subnet. Now, a subnet is going to have rules where it evaluates each rule, and once it finds a match that works, it's going to use that rule. And so if we look at these rules right here, there's 2 ingress and 2 egress rules. And we can see here that they allow 0.0.0.0/0, which is, as you know, the whole internet can go in or out freely in and out of this subnet. So I pretty much know at this point that for my database, I don't really have to worry about the subnets blocking me. The next thing I have to worry about are the security groups. Security groups on Amazon are like a group of rules that can be applied to a resource to say what traffic can go in and out of that resource. So I'm going to look at the security groups associated with my database. I'm going to say, what can get into this database? There must be something out there talking to this database, and that something probably has credentials and code that is used to access this database. So what could it be? So in this case, I'm going to query this particular security group, which is associated with my database. And I can see here that port 3306 is open for MySQL. And I can also see that there's a particular CIDR range, which is 172.31.00.16. So now what can I do? I can look for anything in the account that has that CIDR block range. Now, if it was split up a little bit more, I'd have to do a little bit more advanced querying, but in this case, I simply search for that CIDR range, and I come up with a virtual private cloud. So that means this whole virtual private cloud, anything in it, according to the security group, is allowed to talk to this database. So no subnets, no blocking, and anything in this whole VPC. So there's one other thing we have to look at. Anything that can talk to this database needs to have the proper outbound rules so we can get to this port. So let's take a look at that. We can query for anything in the account that has 3306 outbound open. Unfortunately, when I run this query, nothing comes up. So are we out of luck? You might think so, but no. In Amazon, when you create a security group, the default outbound rules allow everything. And what a lot of developers do is they go in and they want to spin up an instance, and they get to the part about the security groups and the subnets and things, and they're like, I don't know what to do. And it's like, do you want to create a new one? And they're like, well, I don't want to mess up anyone else, so they click the button to create the new one, and they go through the wizard, and there's a little warning there. They might not know what it means, so they just click yes. And you get a bunch of things with wide open outbound rules. Okay, so I can look at all of these things and find out what is using these security groups that has outbound access to our database. So there's two things I can look for. I can look for EC2 instances, and I can look for Lambda functions. So let's look for some Lambda functions. We can query Lambda functions using that particular security group, and we find one here. And this is the Lambda function that Colby created based on the tutorial. And in that tutorial, the developer was probably trying to do a good thing. They're saying, I want this Lambda function to be inside a VPC. I don't want it to be able to be accessible outside, of our private network. So they think they're doing a good thing here. There's something you should know about Lambda functions, and this is where it got really interesting. So Lambda functions, are just like anything else in Amazon, you can run a query, and you can describe that resource and find out things about it. And there's something on a Lambda function called code.location. So I was playing around with this, and I pulled up the code location, and I pulled up the URL, and I looked at it, and I was able to see the code, which is interesting. But what I noticed was when I was looking at this code, I wasn't logged into my account, and I started wondering, how is this authenticating me? And it seems to be a time-based URL. And just to verify that, I sent a text to Colby, and I said, can you see this? And he did not have access to my account. He was not on the same network. We were both at home, and he could also see this data. So what does that tell you? That URL might be a point of risk that you want to make sure you're protecting. In theory, no one can get to that URL unless they have this read-only credentials, but anyone who has these read-only credentials can get this code, and potentially if someone's looking at your network traffic and they see these URLs going across, that could be a problem, so you're going to want to think about that. So I pull up this code, and what's in this file? We have this lovely RDS config file. Oops, we have database credentials. This is based on Amazon's tutorial, and we can see here we have database credentials for super secret DB. Cool, right? So now I can potentially get into this database. But if we think about the Lambda function, I only have read-only credentials, and it might be a little bit difficult. Code is in some bucket maintained by Amazon, because we just use the default. So it's going to be a little bit difficult for me to get code in there, but what else can I do? Well, I can look for things that have access from the internet to the account that are in that particular VPC, and I can try to find something that I can use to traverse from the internet into the account and back and somehow access that particular database. So I'm going to query everything with a public IP address and a public DNS. Lo and behold, we find the lovely WordPress website that Colby set up. What can I do with this website? Well, as we know, the network rules in this account are pretty much wide open. This website setup has outbound access that can freely go to that database, which is not intended to be used with this website. This website has its own database. There's nothing related about them. So what I can do is I can take this database and exploit it, and now we're getting back into the land of regular pen testing and exploiting. We're not going to go there too much, but I will give you one example. I was testing a website and I was able to find that there was a file upload field that was not filtered. You know, you could upload any sort of file to that particular website. And so what I did is like, I can upload code and I can execute my code. So in theory, if the developer makes a mistake, you probably heard there's a lot of WordPress plugins that can be exploited. So one vulnerability, someone gets on that website, uploads their code, gets into the database using the stolen credentials, publishes the data to this website, and takes it out. So that's how they're going to traverse your network.
So to begin with, wow. She got pretty far with read-only credentials. Okay, so now I'm going to kind of go through and let's talk through some best practices that Terry and I come up with and a lot of other people have come up with on how to protect this. So the first thing she exploited was my IAM credentials, so my user credentials. We're going to talk through just some of these things and then also just point out there's some ways to protect this. There's lots and lots of stuff out there. AWS publishes a lot of stuff, Evident.io, and a lot of security vendors, right? One thing I'm going to talk about and really want to leverage is this idea of roles. So AWS IAM has an idea of roles. We'll go through those and how we can leverage those. And also just least privilege. So Terry compromised an account that didn't just have read access to the parts that it needed, it had read access to everything. So even in your read access credentials, exercising a least privilege model. They don't need to see the networking, then don't give them access to the networking. And then you're leveraging segregation of duties. Okay? Does the developer manage the database? In the days of DevOps, sometimes they do, sometimes they don't. And so if they don't need access, don't give it to them. And segregate those duties out, those responsibilities. And then finally, I'm not going to talk about IAM top 10. There's tons of articles out there that talk about IAM top 10. But leverage IAM top 10 rules for security and things like that. So let's talk about protecting the credentials. So the biggest thing here, as Terry started with, is she was able to get this user's credentials. So I think the big step is user training, right? Teach your users how to identify phishing attacks or how to handle credentials securely so that they're not just passing them around. Implement password policies and credential rotation. AWS is fantastic because this is very automated and very easy to do, but leverage these tools so these credentials aren't just hanging out forever. Terry could have exploited something that was older that no longer is in production and grab those credentials. Finally, leverage MFA, right? Add in that extra form of authentication there, and that will help also protect your stuff. We'll talk about MFA and how we can really leverage that in order to protect our credentials. Require frequent re-auth, especially the sensitive apps. This one's kind of annoying because the thing we all hate to do is always have to keep logging in for things. Amazon has a very robust set of SDKs. CLI tools can be easily written to automate this process. It's not as difficult as it feels. You write a little bit of tooling around it, and it's easily done there. And we'll go through some examples on that. And then finally, honestly, a big one is prevent deployment of your secrets to your Git repos or your source control stuff, right? GitHub credentials is a very popular way to harvest credentials. So popular that Amazon scans GitHub and deactivates credentials that it finds. Terry and I have both worked independently at other employers and things and had that happen where you get a notice from Amazon saying, hey, we found your credentials on GitHub, we deactivated them for you. Now AWS Labs, the team that kind of helped came up with that, released the tool so you can actually use that then internally. And that's just as important as external facing Git repos. So protect it all. You set up pre-commit hooks, the link's here and in the slides so you guys can go do that. And it's walked through. By default, it's awesome that it protects AWS credentials, but it is extensible to be able to protect other types of credentials. Okay? So one of the other things we talked about is IAM, okay, and taking a least privilege model. What we recommend is honestly take the least privilege model to the point where they have no privileges. Give your user the base privileges in order to just actually interact with their account. And then from there, we can assume roles into other privileges that allow them to escalate. So here's kind of an example of an IAM template, and that is a lot of YAML. We'll talk through little bits of it. I have it online for you. Of kind of the base profile that we give users. And this is, Terry said we worked together a lot. We kind of came through, and lots of trial and error kind of came up with this, leveraging best practices and different things of that sort. Okay? The first step is to give the users just some basic abilities to actually get into the IAM console so they can actually see the account and do things, right? So there's some base policies that Amazon requires. Again, we're giving least privilege, so we're only giving the bare minimum required here. So that's what this chunk does. They have to be able to get a password policy, so if you implement a password rotation, their account actually has to be able to read the policy to apply that rotation. So that's a big point that needs to be added there. The next step's the interesting step. So in this next step, we're actually going to have to give the user some permissions to modify things about themselves, but we're going to scope it very small. Specifically, really all they're going to be able to do is change their password and set up a few things that AWS needs set up, specifically like SSH keys if you're using some of their tooling, and things of that sort. But you notice we don't ever give the ability for the user to adjust their own permissions. That's controlled via an admin. Okay? We've also scoped this permission, so in that last line we have a scoping command. So Amazon's templating language, we can say only the user that you're logged in as can you change, and so we've scoped it there. So we've again narrowed down what can happen. Okay. The next step though is super important. This is where we start requiring MFA for everything. So again, AWS has MFA just for console logins, but they also have MFA for logging into the APIs. So here we have a bunch of stuff that really helps us implement that MFA. The first few lines are to allow the user to add MFA and manage their MFA device. The last line's really important, and this is where we really are protecting the user's credentials. If they were to get compromised, is you can't remove MFA without having MFA. And so we've protected the MFA token itself. So even if Terry were to compromise a set of credentials here, she can't do much beyond, you know, changing the person's password, but that's not useful because she can't even do anything with the role because she doesn't have MFA to change and remove that MFA or assume roles. Okay? And then in addition to this, we'll then add in the permissions for users to be able to assume other roles. And this is where we kind of get into the meat of this. Is we're going to start separating out each set of action into a different set of roles that allow the user to do things. So now we have segregation of duties just in our permission infrastructure. And we're also going to then require MFA to get into these roles. So they're not just going to be able to get into a role easily and get those credentials in order to do stuff. So we have our user, again, with their base IAM role. That role can't do much beyond manage themselves a little bit and then assume other roles. But we put in requirements in those role assumptions that they have to have an MFA token to even assume those roles. So through an MFA process, they can assume the role and actually then gain the permissions that they need. Now, a nice thing about these roles is their timed access. Previously, until a few weeks ago, they were only timed for an hour at most. You couldn't get them for any longer. Amazon has released some features to allow you to make it a little bit easier for users by extending those timings. But you're going to get back a set of temporary credentials that then elevate your access to be able to do what you need to do at the time that's set. They'll expire, and then we don't need to worry about them because they're automatically deleted and no longer good. And then also we're forcing our users to then only elevate to the permissions that they need. If they're going in and doing some stuff in Lambda, there's no reason they need to really be able to adjust networking or security groups if they're just trying to load in new Lambda functions through the console or through the API. So what does this look like? So I took Terry's commands previously, and I ran the same command leveraging this type of methodology. So we see at the beginning, I have an IAM user that has no rights to do anything. We get a permission denied. I then make a call to Amazon's API to assume the role, and I gave it an MFA token, right? I required an MFA token. I'm going to get spit back out at me a bunch of credentials that I can then leverage in order to access things within it. The big thing to point out is these credentials give you the expiration time, so we know that they're not just going to be living around forever. I can then leverage those credentials, run the same command, and get the stuff that she has. An hour later, I don't care. Those credentials are gone. We don't have to worry about them. They're automatically rotated out. Okay? And this is also what we mean by frequent reauth, right? Is keep these credential lifetimes short for sensitive areas and having users reauth via any type of tooling that you've written in order to get access. Now, another wonderful feature of Amazon is CloudTrail. So CloudTrail is a tool that Amazon provides that lets us monitor API calls. Okay? So all of these actions that we're doing and all of this rigorous permission structure we're implementing is also then just logged and monitored for us. And so we can enable this in our account, leverage it, and do some cool things with it. More importantly, like most AWS tools, and being an event-driven infrastructure, we can send this stuff off to events and watch it, monitor it, and act on it. And so here we kind of draw an example of leveraging CloudTrail, feeding these events to the event bus, having a Lambda function that processes these events and decides, is this a valid event? Does this fall outside of what is normal? If you know your developers aren't going to be deploying code after 9 o'clock at night, you shouldn't have credentials escalated into those roles after 9 o'clock at night. You can catch it and either alert or remediate the action immediately and not have to worry about waking up in the middle of the night and catching this. Okay? And so we can leverage those tools. So that's how we can protect users. The next thing Terry did was exploit a set of credentials. Okay? So I can't really protect that Lambda function the way it's called into Lambda. That's just a feature of how Amazon was built. So we can though protect the credentials, and Amazon provides some methodologies for protecting the credentials. Now, I want to note, Amazon kind of stole our thunder on this slide 2 weeks ago because they released AWS Secrets Manager, which automates some of this for us. So we're kind of going to talk about the old way to do it. They do have a new tool that was released that can help you do this also, but it's important just to kind of illustrate the role access here. Okay, so we're going to leverage what's called EC2 Parameter Store. So it's just a secure storage place inside of Amazon's infrastructure. More importantly, it's bound by IAM roles, and we can limit access to it. So in this case, we have an administrator who has access to seed credentials into the secret store, but doesn't really have permissions to remove or delete those credentials. Okay? They also have the ability to leverage custom encryption keys to encrypt data. They don't really have permission to decrypt the data. So we've segregated who can seed the credentials. That person can't remove or delete the credentials. We can then give any of our services within Amazon rights to then leverage those credentials through IAM, so they can log, we can give an EC2 instance or a Lambda function, the ability to read the parameter store and to decrypt the parameter store and pull out very specific sets of credentials associated with it. So we're no longer having to seed credentials into an S3 bucket, which in the S3 bucket with encryption are fairly safe. We've added an extra layer because they're on demand getting these credentials. We can rotate it and initiate a new credential pull pretty easily. Okay? So what does that look like? We take the same set of code on the left, which is what Terry pulled up. I then modified this set of code to leverage EC2 Parameter Store. We looked at in the configuration file, it no longer has the secrets. I've added 3 lines of Python to pull the credentials out of the parameter store and decrypt them. Super easy to do. It's not a lot of code. It's really automated on the back end for us. It then pulls these secrets at runtime out of the parameter store and leverages them. So no longer are we burning these secrets in. We're protecting the secrets that Lambda function is. So Terry can download that Lambda function and see all of our code, but she can't get into the databases. So we've protected those. So a lot of that is preventative. We can also go reactive. So AWS has some tooling that will let us do some reactive monitoring and remediation against stuff there. So we have AWS GuardDuty. This is a fairly new tool that they've released, I think at reInvent this last year. And what it's an amazing tool, very cool tool. But it monitors flow logs, DNS logs, and those CloudTrail logs and builds up kind of a profile of what your account does. And so we can actually then generate alerts and remediation steps off of that based off of what is an acceptable profile on our account. It also, since it's monitoring DNS and flow logs, can also build those heuristics on traffic patterns of your infrastructure. Okay? AWS also has, as we talked about, CloudTrail. They have a tool called AWS Config. That tool is a very fun tool to play around with, especially if you forget that you have it installed. It will roll back changes that are authorized within it. And so if you forget that it's on, it can cause some fun situations. Log shipping and protecting your logs and securing your logs is another way to kind of continuously monitor this thing. And then if you're leveraging AWS tools, leverage their automated remediation ability, specifically serverless type methods, in order to disable, remove black hole servers for later forensic investigation so that you can see what's going on. We talked about GuardDuty. Sorry. This is just an example of a GuardDuty log. So it does build these logs for us. So these are the types of event trails we have here. Some cool things here is it does block or detect Tor exit points, SSH brute force attacks. some type of crypto things running on AWS to really protect things there. Okay. The other thing she compromised was our WordPress site. So Amazon provides a lot of tooling to protect the WordPress, or to protect your websites. So here's just kind of an example of all of their edge tools. I'm not going to go into these very deeply, but we're not talking about DDoS. So AWS Shield is a DDoS protection tool. But the one we do want to talk about is CloudFront and WAF. So we can, leverage AWS's CDN and put a WAF in line, protect us against cross-site scripting and things of those sort. Put an Elastic Load Balancer behind that, and now you're not directly ever accessing your application, and you're putting in these layers of protection to make sure that things are protected there. The final thing she was able to do is attack our network. So originally we had a wide open network. It's worthwhile on AWS to follow networking best practices. So we're huge fans of the three-tier network architecture where we have a presentation layer, an application layer, and a data layer. Within that, we're going to limit where they can access, limit the NACLs and the security groups, and then potentially also start limiting outbound traffic. So as an example, here's our bad network. So NACLs, as you saw, were wide open inbound security groups. Security groups put everything talking to the internet, so they can kind of just do whatever they want. A better method is to implement this three-tier architecture and really start wrapping these things out with more fine-grained controls. So here we've only let certain things talk to each other through security groups. We've protected our subnets so that the front end can't actually talk to the back end subnets or the database subnets. And then in all honesty, if you're leveraging a lot of AWS or cloud tools, a lot of your services don't really even need to talk to the internet, right? You're using CI/CD automated deployment mechanisms, leveraging AWS tooling or any other cloud provider tooling, you can limit the internet access. And so in a lot of cases, we shut off internet. Specifically if we're leveraging Amazon RDS databases, that layer doesn't need internet. That's all managed in the background by AWS. So just turn it off if it's not needed there.
Okay, so as we can see, we showed you that the same tools that your developers are using can be used by attackers. So the same powerful things you can do to automate in your environment, they can use to automate their attacks. And those cloud APIs can really be used for reconnaissance in your account. They can get a complete inventory, they can kind of back their way through, map out an account path in and out of your account. And additionally, we've shown you that read-only access can actually be very powerful.
And then from a protection perspective, restrict access. You don't have to give everybody read access to everything. We didn't talk about automation, but automate the deployments, leverage the tools. It helps limit internet access and things of that sort if you're leveraging those automations. Architect your networks to minimize all the open porting and thus minimizing pivoting. Protect secrets. Don't embed them in the code. Don't embed them in repos. Leverage secrets protection mechanisms. We've illustrated, again, AWS's tools. There's tons of tools on the market to help you with that, to be able to do that. And then finally, if you're in the cloud, monitor everything. It's all available to you, so monitor it. Make sure that you're watching what's going on, alerting, and then you can start building remediation against those things. So you're not dragging security engineers or engineers out of bed in the middle of the night to prevent hacks. So we just wanted to thank you guys for coming to our talk. We hope you learned something and enjoyed it. We're available for any questions that you guys have.
And you can follow us on Twitter.
And you can follow us on Twitter.
Yeah, I'm ready. Just a quick question. I think a lot of times, by the way, thanks for the talk. That's very, very, very useful. A lot of times, a lot of the best practices are out there. But at the end of the day, what the security folks have to do is give very easy way for engineering teams to pick up a CloudFormation stack, for example, and run it before they actually do anything in their AWS account. So do you have any recommendations or any resources where, I can go and say, give me all the CloudFormation stacks that I can say, or automate myself as an account is spun up or is created in AWS footprint of my company, let's say. I mandate the execution of a CloudFormation stack, which has the base policies, and then another CloudFormation stack, depending on the use case of that account. So, are there any resources that give me some of those resources, or pre-built stacks. Does it make sense?
Yeah, I think I'll start and I'll let Colby follow up because he did a lot of the kind of the hands-on work at WatchGuard. But definitely, this was in my paper. As a big idea is having that CI/CD system, and it's really interesting. Warner Vogels at the San Francisco Summit 2 weeks ago said the same thing. You should really bake security into your CI/CD pipeline. And then also was also mentioned here, if you saw the AWS CISO, Stephen Schmidt, he was here and he said, he talked a lot about this. So I would recommend going and taking a look at his talk. But definitely set up a base policy and have an automated way for developers. In our case, we had a way for them to go in and run a job. And they had base templates they could select. And if they're really ambitious, we allowed them to edit certain things, but not other things, depending on their role. So they could modify it. They weren't stuck with what we delivered, but they had to, as the same thing Stephen Schmidt said, everything had to be put into code, checked in, and deployed that way. And even, we had a small company. I couldn't check everything when I came in, so we had to start somewhere. We started with the pipeline, and then as you find problems, you can build on that and add security in over time.
As far as your question on where to find resources for CloudFormation templates, there's a lot of stuff out there. But in all honesty, Amazon's CloudFormation documentation is good. Just read through it. And a lot of what I did was we would effectively click through the console and write the CloudFormation at the same time, delete it, run the CloudFormation. So there's a lot of iterative back and forth testing in order to do that. The one thing though is minimize the complexity of your CloudFormation templates, stack them. So a lot of what we've built is the networking CloudFormation was always in a different set of CloudFormation templates than to deploy a microservice on top of a container system. And so that way, the people that are more specialty are focusing on their stuff. You're not having someone try to learn all of CloudFormation. The other useful tool is honestly the CloudFormation templates names match the SDKs. So if you can write code in the SDKs, you can usually backtrack into what CloudFormation has in order to try to build the templates. But to reiterate, at WatchGuard, nobody ran templates by hand. Everything was integrated into CI/CD. We had a core team that kind of validated the templates, the people who knew how to write them a little bit more to make sure they were right. But a lot of it was trial and error. With CloudFormation, that automation, it's really easy to destroy and rebuild, destroy and rebuild, destroy and rebuild.
So thanks for that talk. It was a fascinating structure that you guys came up with, so well done. Sort of a problem I'm very worried about, whether it's individuals using cloud services or code that they write, that they put on cloud services, are screw-ups where data or code is protected insufficiently. And we've all heard about people putting things in public S3 buckets. That's sort of the stupidest case, but there's lots of other cases where something is out there with more privilege than it should have. How do you go about detecting that or imposing processes that will find those sorts of mistakes?
Exactly. I actually wrote a couple of articles on S3 Bucket and did a talk at the Cloud Summit on that topic. It's a lot more than just a bucket policy, right? That's part of what the whole CI/CD platform is about. You have a way to monitor everything. If you're just letting people willy-nilly throw stuff out there you don't know. I was also just talking to a CISO and I said, what do you think the biggest priority is in security? And he said, know where your data is. So you can leverage your CI/CD system to know where your data is. At Capital One, we enforce encryption of everything, just period, everything. It's easy to do in the cloud. You can check a box, you can write policies, you can say you cannot put something in this bucket unless it's encrypted. So you can use policies for that. So I really believe the CI/CD system is a huge part of that.
As far as cloud native tools go, this is where AWS config comes in. You have your security team really define the rules. So config, as I said, it's an interesting tool because it does what it's told to do and doesn't do more or do less. And so, if you're mandating no public buckets, you want to front all your buckets by CloudFront, which is a good practice. Config can make sure that no bucket does that. AWS has a lot of other tooling just built into it, Trusted Advisor, some type of scanning. There's a bunch of third-party tools that will also scan your accounts and leverage that. But honestly, I just kind of take more the jerkish approach and just don't give people permissions until they need them, right? And so, you're going to have nothing until you ask me for something. And so, we can take that approach with our own team, right? I mean, we ourselves, there's a few of us through change management and internal policies that can elevate to a higher level. But again, we're doing this elevation. Like, so this model that I talked about with role elevation, it's what we do at ZipWhip. Like, none of us have by default write access or read access. And so we're able to track that. And so anytime it pops up into a higher level, we can get alerting out of that and pop a pager alert or something like that, so that you can see, okay, they've gotten approved through change management and so on to be able to do those types of things.
Any other questions? Okay, thank you very much.
Thank you.